Surface areas and volumes.
This is the topic conversion of solid from one shape to another.
We have started the topic in the last lesson, conversion of solid from one shape to another. Here the point is, if we recast one 3D figure into some other 3D figure, in different way you can reshape it. However it is, the volume will remain unchanged. That's the point. If you recast one 3D figure into two other 3D figure, some of the volumes of the two new 3D figures will be same as the old one. So that's the concept here. I explained in detail in the last video. If you didn't watch that video, you can get that video from the description. I have given link to the playlist of chapter number 13 surface areas and volumes in the description. Also the videos of other chapters you can find out from the links in the description. If you didn't subscribe my channel, please consider subscribing, and also if you like this video, please share this video to your friends. We move to next question in the same topic.
And next question is like this. This is a little bit longer one. Okay. Look here, Selvi's house has an overhead tank in the shape of a cylinder. And this is filled by pumping water from a sump. Sump is an underground tank, which is in the shape of a cuboid. The sump has dimensions 1.57 meter into 1.44 meter into 95 centimeter. And the overhead tank has its radius 60 centimeter and height 95 centimeter. Find the height of the water left in the sump after the overhead tank has been completely filled with water from the sump which had been full. Compare the capacity of the tank with that of the sump. Okay, the question is like this. In Selvi's house, there is a tank. There's some water tank or something in the shape of a cylinder. Okay, so in his house, suppose this is his house. So overhead there is a water tank in the shape of a cylinder. Okay, its dimensions are given. What are the 60 centimeter and the radius is 60 centimeter and the height is 95. Radius is given. Radius is given that 60 centimeter and height is given that 95 centimeter. Okay, and they are pumping water not from the well, but it is called from one some sump, some underground something. Okay, so in some flats and something they have such arrangement sump. So from tanker lorries they will fill sump first, then from sump they will pump to local tanks. Okay, so suppose there are some underground sump here in the shape of a cuboid. It is told that the sump which is in the shape of a cuboid. Okay, so some underground sump is here like this. Okay, so from in the beginning the sump is full of water. Sump is full of water in the beginning, and from this sump we pump water into the cylinder. Okay, and what is asked? Find the height of the water left in the sump after the overhead tank has been completely filled with water from the sump which had been full. Okay, so suppose before starting the pumping, suppose this cuboid is full of water. So after pumping, after making this cylinder full of water, pumping water from this cuboid to the cylinder, what will be the height of the water level, water left in the sump after the overhead tank has been completely filled? Okay, I shall take some other color. Okay, after filling the full of water in the cylinder, suppose the water level comes only up to this much. So you want to find the height of the tank up to which the water level remains. That's what the question. Okay, the dimensions of the cuboids are also given. So here what is the concept?
Volume
Volume
of cylinder.
volume of this cylinder you subtract from volume of this cuboid. So the remaining will be the volume of the remaining.
Non-cuboid.
Yes, if you subtract the volume of the cylinder from the volume of the cuboid, you will get the remaining volume. That means the remaining volume of the, suppose this itself we can consider as a cuboid. The cuboid up to which the water remains, we can consider as a cuboid. For this small cuboid, you substitute the volume will be the volume of the full cuboid minus volume of the cylinder. So that can be calculated in numbers. So using the formula here, the h we can be considered because the other dimension will remain unchanged, right? So the dimensions are 1.57 into 1.444. Those two will be remain unchanged. 1.57 and 1.44 will be remain unchanged. So using the formula LBH formula, we can substitute these two values, and the volume will be in numbers we can calculate. Then doing some reverse step, it will be able to find the height of the remaining water. Okay. Usually it gives in the order length into breadth into height. Okay, so 1.57 should be length, then breadth, then height. Okay, here centimeter, you want to take all the measures in the same unit. So you can either make everything in centimeter or in meter. So we can discuss as it is taken in the textbook. Okay. So look here, the volume of the water overhead taken equal to the volume of the water removed from the pump. Okay, that we discuss. The volume of the water in the overhead tank, that we can calculate first, pi r square h, volume of the cylinder, the formula pi r square h, we can substitute the values. So it is taken in meters. So given measures are in centimeter, to make every length in same unit. So the centimeter measures are converted into meters. So here for the cylinder, the measures are given 60 centimeter, 95 centimeter, the radius and height. So 0.6 meter and 0.95 meter will come. Okay. So look here, 3.14 into 0.6 into 0.6 into 0.95 meter cube will be the volume of the cylinder. We are not going to find the final answer because that is not asked. We don't have to find the volume of the cylinder. So we just keep like this. Then the volume of the water in the sump when full volume of the cuboid will be LBH, that is 1.57 into 1.44 into 0.95 meter cube. Okay, so the volume of the water left in the sump after filling the tank will be the volume of the cuboid minus volume of the cylinder. So subtracting this, you can simplify into 1.57 into 0.6 into 0.6 into 0.95 into 2, and that will be the volume of the remaining cuboid. That means the cuboid with height having the remaining water. Okay, so the height of the remaining will be volume, this volume divided by L into B, because L into B into H will be volume of the left in the sump. So H will be this volume of the water left in the sump divided by L into B, because the volume formula is LBH. Okay, so we know L and B, you substitute here, then divide, you will get to 0.475 meter. So convert to centimeter, you will get to 47.5 centimeter. Okay, so it is also asked to compare the capacities of these two tanks, this cuboid and the cylinder. Suppose we take a capacity of the tank, the cylinder, by capacity of the sump. So these values we can substitute, these two values. So some numbers will be cancelled, 0.95 will be cancelled, and 1.57 in 3.14 2 times will go. The other numbers you divide, finally you will get 1 by 2. That is half the volume. The tank volume is half that of the sump. Okay, that's what the height is also became half. right? In the beginning, the height of the sump, the water level was full, that is 95 centimeter, and when the tank made filled full, the remaining height of the water level were, we got 47.5, that is just half of 95 centimeters. Okay.
I hope the answer is clear. If you like this video, please don't forget to press the like button and also share this video to your friends. To get more videos like this of the same chapter or other chapters of class 10 CBSE mathematics, please check in the description of this video. I have given the links to playlist of other chapters and this chapter in the description. In the next videos, we will discuss some of very important questions from the same topic, conversion of solids from one shape to another. Until then, bye.